This video helps us in understanding the range of the inverse trigonometric functions: sine inverse, cos inverse, sec inverse, cosec inverse, cot inverse, and tan inverse. A function f is invertible if and only if f is 1 to 1. We denote the inverse of f as f inverse. In order to define an inverse for any function, we need to identify a part of its domain over which the function is either decreasing or increasing, and hence 1 to 1. So, in order to find the domain and range, we need to find a part of the function, the graph of the function, where it is either decreasing or increasing. We start with the function sin x. The domain of sin x is R and the range is the closed interval -1 to 1. If we restrict the domain to -π/2 to π/2, both inclusive, then f, the function sin x, is 1 to 1. So domain of sin inverse is the range of sin, that is -1 to 1, and the range of sin inverse will be the closed interval -π/2 to π/2. So looking at the graph of the function sin x, if you look at the interval -π/2 to π/2, the function is increasing in this interval. So over this interval -π/2 to π/2, the function is 1 to 1, and hence the range of sin inverse is the interval -π/2 to π/2. If paying attention to the graph of the function, we can see that between -3π/2 to -π/2 and π/2 to 3π/2 also the function is decreasing, and hence 1 to 1 in this interval. But when we choose the range, we choose the interval which is closest to 0. Hence we take the range of sin inverse as -π/2 to π/2. So the graph of sin inverse, the domain is -1 to 1 and the range is -π/2 to π/2. This would be the graph of the function sin inverse x. Coming to cos x, the domain of cos x is R and the range is the closed interval -1 to 1. Again, cos x is not 1 to 1, but if we restrict the domain to the closed interval 0 to pi, then it becomes 1 to 1. So the domain of cos inverse will be the range of cos, which is the closed interval -1 to 1, and the range is 0 to pi, because in this interval 0 to pi, the function cos x is 1 to 1. So if you look at the graph of cos x, this is the graph of cos x. Within the interval 0 to pi, the function is decreasing and hence 1 to 1. So this would be the graph of cos inverse x. The domain is -1 to 1 and the range is the interval 0 to pi. The graph of cos inverse x. Coming to tan x, domain of tan x is the set of real numbers except odd multiples of pi/2, because tan pi/2 is infinity, tan 3π/2 is infinity, and so on. The range of tan is the set of real numbers. Again, the function tan x is not 1 to 1, but if we restrict the domain to the open interval -π/2 to pi/2, the function is 1 to 1. So tan inverse, the domain would be R, which is the range of tan, and the range of tan inverse would be the open interval -π/2 to pi/2. This is the graph of tan x. Within the interval -π/2 to pi/2, the function is increasing and hence 1 to 1. We have mentioned the open interval -π/2 to pi/2 because the graph of the function comes very close to -π/2 and pi/2, but it is not touching -π/2 or pi/2. It goes on to infinity and -infinity. So the domain of tan inverse, this is the graph of tan inverse. The domain is -infinity to infinity and the range is -π/2 to pi/2. This would be the graph of tan inverse x. Next, coming to cot x, domain of cot x is R except even multiples of pi/2, because cot pi is infinity, cot 2pi is infinity, the range of cot is set of real numbers. Cot is not 1 to 1, but if we restrict the domain to the open interval 0 to pi, the function is 1 to 1. So domain of cot inverse is R and the range of cot inverse is 0 to pi. This is the graph of cot x. Within the interval 0 to pi, the function is decreasing and hence 1 to 1. And this is the graph of cot inverse x. The domain is minus infinity to infinity and the range is 0 to pi. The open interval 0 to pi. It comes very close to 0 and very close to pi. Coming to cosec x, domain of cosec x is R except even multiples of pi by 2 because cosec pi by 2, cosec pi is infinity, cosec 2 pi is infinity, and so on. The range of cosec will be the open interval minus infinity to minus 1 union 1 to infinity. So points between minus 1 to 1 are not included in the range of cosec x. If we restrict the domain to the open interval minus pi by 2 to 0 union 0 to pi by 2, then the function is 1 to 1. So this is the graph of cosec x if we restrict the domain to the open interval minus pi by 2 to 0 union 0 to pi by 2. The function is decreasing in this interval and hence 1 to 1. So the inverse of cosec is defined in this interval minus pi by 2 to 0 union 0 to pi by 2. This is the graph of cosec inverse x. The domain is minus infinity to minus 1 union 1 to infinity and the range is minus pi by 2 to pi by 2. And y not equal to 0. So we don't take the point 0 in the range. So technically the range is minus pi by 2 to pi by 2 minus 0. Coming to sec x, domain of sec x is R except odd multiples of pi by 2 because sec pi by 2 is infinity, sec 3 pi by 2 is infinity. The range of sec is the open interval minus infinity to minus 1 union 1 to infinity. Again, sec is not 1 to 1, but if we restrict the domain to the closed interval 0 pi minus pi by 2, then sec becomes 1 to 1. This is a graph of sec x. If we restrict the domain to the closed interval 0 to pi by 2, not including pi by 2 to pi by 2 to pi, it is increasing in this range and hence 1 to 1 in the interval 0 to pi by 2 and pi by 2 to pi, not including pi by 2. This would be the graph of sec inverse. The domain is minus infinity to minus 1 union 1 to infinity and the range is 0 to pi and the range does not touch pi by 2. So summarizing all that we have just gone through, the domain of sine inverse is minus 1 to 1, range is closed interval minus pi by 2 to pi by 2, domain of cos inverse is the closed interval minus 1 to 1, range is the closed interval 0 to pi. So domain of sine inverse and cos inverse is the same, that is the closed interval minus 1 to 1. This helps us to recollect. Domain of tan inverse is R, range is the open interval minus pi by 2 to pi by 2. Domain of cot inverse is R, range is the open interval 0 to pi. So domain of tan inverse and cot inverse is R, which is same as the domain of sine inverse and cos inverse, which is minus 1 to 1. The range of tan inverse is the open interval minus pi by 2 to pi by 2. Range of cot inverse is the open interval 0 to pi. Sec inverse and cosec inverse have the same domain, that is R minus the closed interval minus 1 to 1. Range of sec inverse is the closed interval 0 pi minus pi by 2. Range of cosec inverse is the closed interval minus pi by 2 to pi by 2 minus 0. So that coming to an end of this video. For any queries, you can contact me on matthews.suman@gmail.com.